we're talking about solving systems of equations by graphing. So in this first section, we're going to be graphing, but instead of doing one equation on a graph, we're going to be doing two equations on a graph. When we're looking at two equations on a graph, we're looking for a solution. The solution being where those 2 points intersect. So we have three different options of solutions that we could have. We could have one solution where those two lines are crossing at one particular point. And we would say that point as an ordered pair. X, comma, Y. If we have two lines that are never crossing, that they're parallel, they would have no solution. Then our third option is infinite solutions. This is where the two lines are overlapping. They're exactly the same. It's hard to tell, but this has another line underneath it. Those two lines are exactly the same, meaning they are overlapping across the entire graph. So we're going to practice this on some examples. Example 1, it says we have to graph y equals negative 2x minus 4 and y equals 1/2 x plus 6. So I'm going to graph these two lines, and I'm going to graph them in different colors just so you guys can tell the difference. So starting off with negative 2x minus 4. I'm going to begin on my y-axis at negative 4, and then my slope is negative 2. So I'm going to go down 2 and right 1. And I'm going to continue that across my graph as far as I can. When I run out of space, I could also go the opposite way. Instead of down 2, right 1, I could go up 2, left 1. So this is really important to make sure you really are doing this all the way across the graph, because we are looking for such specific points of where they're crossing. So make sure you're plotting as many points on your graph as you can. Okay, now I'm going to graph 1/2 x plus 6. So I'm going to begin on my y-axis at positive 6, and my slope is 1/2. So I'm going to go up 1, right 2, as far as I possibly can. Once I run out of space, I could also go the opposite direction. Down 1 and left 2. As far as I possibly can. Once I graph those two lines, I can see that they crossed at this point right here, which is the point negative 4, positive 4. So that is my solution, the point where they cross. Now, I can check that this worked for my equations. That means that that point, negative 4, positive 4, should be a solution to both the equations that I tried. So I'm going to check that by plugging in negative 4 for x and positive 4 for y into both of my equations. So in the first equation, y equals negative 2x minus 4. X is going to be negative 4. And y is going to be positive 4. So that means that all of this stuff on the right side should equal positive 4. So I'm going to get out my calculator, and I'm going to plug all of that into my calculator. So negative 2 times negative 4 minus 4 does equal positive 4. So that means it worked for that equation. But it has to work for both equations. So I'm going to plug that same negative 4, positive 4 into my other equation of 1/2 x plus 6. So into the y is going to go positive 4, and into the x is going to go negative 4. So this side of the equation, again, should end up equaling the left side, which is positive 4. So I'm going to plug that into my calculator. So 1/2 I have a fraction, I have to type it in parentheses, times a negative 4 plus 6 does equal a positive 4. Since that point, negative 4, positive 4, worked for both equations, I know that my solution of negative 4, positive 4 was correct. Okay, let's try example 2. Same thing, we're graphing both of these lines. Now, on both of them, they don't say y equals. So in order to graph, I have to put them in y equals mx plus b. So for my first equation, I see that I have y minus 2x. So I'm going to fix that by adding 2x on both sides. So that gives me y equals 2x and a positive 6. So when I go to graph that, I'm going to begin on my y-axis at positive 6, and my slope is positive 2. So I'm going to go up 2, right 1, as far as I can go. Once I run out of space, I can go the opposite direction. Down 2, left 1, as far as I possibly can go. Then I'm going to connect my dots and make my line. For my second equation, I have to do the same thing. I got to solve this for y. So I see a negative 4x. If I add 4x to both sides, we're starting to get that y alone. So that would give me 2y equals a 4x and a positive 8. Then I have 2 times y, so I need to divide everything by 2. So that's going to give me y equals 4 divided by 2 would give me 2x, and 8 divided by 2 would give me positive 4. So I graph this, and I'm going to begin on my y-axis at positive 4, and then I'm going to do my slope up 2, right 1, up 2, right 1. If I want to go the opposite direction, I can go down 2, right 1, as far as I can go. And I'm looking for where my lines are crossing. But I can tell that these lines are parallel. That's because they had the same exact slope. So since they are parallel, that means they're never going to cross. That means we have no solution. If they're never crossing, we have no solution. Okay, let's look at example 3. Same thing, we have to graph both of these lines. With this first equation, it's already in y equals mx plus b. So I'm just going to start off with graphing. And I'm going to begin on my y-axis at positive 9. Then my slope is really a negative 1. So I'm going to go down 1, right 1, as far as I possibly can go. If I need to go the opposite direction, I can go up 1, left 1. And connect my dots. Alright, then with the second equation, I need to solve that one for y. I see a 2 times y. That means I need to divide everything by 2. So that's going to give me y equals negative 2 divided by positive 2 is going to give me a negative 1x. And a positive 18 divided by 2 is going to give me a positive 9. So I'm going to start on my y-axis at positive 9, and my slope is negative 1. So I'm going to go down 1, right 1, and look at that. We have the exact same equation, exact same line, which means that these two lines are overlapping across the entire graph forever and ever, which means we have infinitely many solutions. Forever and ever, all the numbers that I could plug in into these equations would be correct. All the points are overlapping. Okay, let's look at example 4. What is the solution to this system below? They already graphed it for us. We just have to find the answer. So I'm looking for where these two graphs overlapped, which I can see right here is where they intersect. And that point is 3, positive 2. So I have to write that as an ordered pair, x comma y. 3, 2 is the solution to this graph. In example 5, is 2, negative 4 a solution to the system of equations? So they gave me the answer. I have to go back and check that these x's and y's work for both equations. So the 2 was our x, and the negative 4 was our y. So I'm going to plug that ordered pair into both points, in for x and y. So x was 2 minus the y, which was negative 4, and that should equal 6. Well, I can see that I have a double negative. That's going to turn into a positive, and I know that 2 plus 4 is 6, so that point works for my first equation. But I can't say that this is the solution until I check both equations. So now I'm going to go and I'm going to plug it into my next equation. 2 times x, which was positive 2, plus my y, which was negative 4, should equal 0. Well, I see 2 times 2 is positive 4, plus a negative 4. 4 plus a negative 4 is 0. So since it worked for that equation too, I can say yes. 2, negative